All right, this section is for precipitation reactions, and we're going to be looking at what the precipitation reactions involve and some details about how to reduce them into net ionic equations. So first thing is you're going to notice that we do need to know what a precipitate is, and that's a formed solid. Most of our precipitates are going to be actually ionic compounds, as opposed to, forming a metal or maybe making a covalent compound. A precipitation reaction then needs to actually be a reaction in which a precipitate is formed. Oftentimes they're going to be double replacement, but they won't always be double replacement. So we're going to take a look and notice we're still following all of the same rules that we did before as we were making molecular equations and then switching them into net ionic equations. Again, this is going to be a nice practice as you go through of reviewing what your ions are. And so we're going to start out, right? We've got a solution of tin 4-chloride. And since it's a solution, that means that we know it involves water. And again, this unit, we're assuming all of the solutions are in fact with a solvent of water. We have also some sodium phosphate, which is also a solution, and so we know that that's going to be aqueous as well. Since this is a double replacement reaction, we're going to have our tin joining up with the phosphate ions. And again, since phosphate is -3, we'll need 3 tins, and 10 is +4, so we'll need 4 phosphates. We'll leave our phase free right now and open. And over here, we'll also have some sodium chloride and looking at that phase. So if you remember, as we decide what kind of phases they are, we want to look for an ionic compound. Tin is a metal, so we know that this compound is ionic. And sodium is a metal, so we also know that that compound is ionic. And we also want to be able to see them in some sort of solution in water. At that point, you switch over to your solubility table. And if you remember, all sodium ions are soluble all the time. So our sodium chloride is going to be soluble. Excuse me. And then our phosphate we see here, most of those are actually going to be insoluble. So our tin phosphate is going to be insoluble. So we now come back over and we know our sodium chloride is aqueous. Our tin phosphate is a solid. At that point, you're going to want to switch them into an ionic equation. So similar to how we were doing before. Again, as long as it is soluble and ionic, you're going to turn it into ions. The thing that is not going to be written as ions is this solid, which is in fact our precipitate. And you would then watch as the precipitate fell out of solution. You'd be able to see a solid actually chunking out into the bottom of the beaker. All right, so there is our ionic equation. So let's switch it over to a net ionic equation by just removing our spectator ions. And remember, that's going to be anything that was not altered at all. And then that's your final form of your precipitation reaction. All right, let's take a look at a couple of other examples as we turn the page. One more is the solutions of silver nitrate and potassium carbonate are mixed. And so again, you're just going to write your silver nitrate formula. Again, you're being told it is a solution, so that's going to be aqueous. And then we've got our potassium carbonate, also a solution. And again, if you notice, right, we've got just 2 ionic compounds, so this is again going to be double replacement. So we're going to join our potassium to the nitrate ion, and we'll join our silver to the chromate ion. And again, as you get your products written out, you want to go back over to your solubility table. And as we look at our potassium and our nitrate ions, we see that, yep, they're always going to be soluble. Our carbonate, on the other hand, is now being joined with silver, so that's going to fall into the most category. So we can go back over, and as we take another look, we're going to change them into their ions after we make sure we remember which one is aqueous and which one is solid. And again, so that means we're going to see a silver carbonate precipitate out of the solution. As you change it into your ionic equation, again, anything that is ionic and soluble is going to be written as ions. Oops, I don't want that. So ions K plus and CO3 minus 2. Our potassium nitrate is also soluble as well as ionic, so we're going to write that as ions. And then our silver carbonate is our solid, so we're going to leave that in solid form. And then just to wrap up, we would convert it into a net ionic equation by just removing anything that was a spectator. So potassium ions would be spectating, nitrite ions would have spectated also. And now we can see a very reduced amount of information for a net ionic equation, just showing the silver ions joining the carbonate ions to make the silver carbonate.